Hasan, a lot of people are talking about the new ISO 21434 standard. What do you think? Do you like it? Is it good? Is it bad?
It's certainly good. I mean, standard is always good, but this particular one is very well written. I really like the definitions I really like there's examples. The standard is very well written and it goes hand in hand with ISO 26262 and the other existing standards. So I think it's good material. It's a good place to start. In terms of content, there are certain areas where I personally think there could be some in-depth. For example, one part is the definition of CAL. It's pretty much two-dimensional. One dimension is talking about the accessibility. One dimension is talking about the severity, which is understandable. I think what I would recommend people using that standard or definition in order to determine your CAL level, please also incorporate the knowledge level required for the attacker when you will define your cybersecurity assurance level. This is something that is mentioned in the standard here and there, but not explicit while you are defining your CAL level.
The ISO 21434 standard is based on several other standards that have already been published. Can you tell us a little bit more about those standards?
So, like I said, this standard is very compliant to the existing standards. So one of the inputs that has been taken for this standard is ISO 26262, and it kind of supersedes the guideline from SAE, the J3061 guideline, which is the cybersecurity engineering guideline that we had so far. We still have it. Other than that, the standard also have taken input from IEC 61508, which is the safety standard for electronic system. And the standard also have taken input, especially in risk management and the management level of cybersecurity, from ISO 31000, the cybersecurity standard for risk management, cybersecurity.
And could you give an example on what has been taken from standards?
Good question. So, for example, we are very familiar with whoever is working in automotive engineering is familiar with ISO 26262, a standard that has been out there for a long time. Something that is very similar to ISO 26262 is the CAL level, cybersecurity assurance level, and also the prescriptions that for certain security assurance level, you have to do this much of testing, which is, this is mandatory, this is recommended, this is nice to have. Also, the notations that has been used is very similar to ISO 26262. In fact, the kind of the test they're talking about is also the same kind of test they're talking about in ISO 26262, which is a good thing in a sense that you can take advantage of one another. So the safety people and security people, they don't have to say that, oh, I'm safety, I have nothing to do with security, and the other way around. You can actually work together and save money because a lot of your test cases from safety perspective or the other way around from security perspective will actually be covered by safety cases and also security cases. So you can take advantage of those two.
One thing that is in the ISO 21434 standard is the CAL, the cybersecurity assurance level. Mm-hmm. Can you tell us a little bit about this? What is it?
So the cybersecurity assurance level is nothing new. It has been out there in other domains. In some domains, it's called security assurance level. So it is there to mean that how secured your system is in a numeric way, in a categoric way. And also, it's nothing new for the automotive industry. ISO 26262 have this automotive safety integrity level, ASIL, for a long time now. We talk about ASIL A, B, C, and D. Depending on certain criteria, we define the safety integrity level. How safe the system is, how much trust, in a way, can you put in your system. So CAL level is a parallel of that. When you will build a system, an ECU, and your ECU will be assigned a CAL similar to an ASIL. And when, depending on what CAL level you'll be assigned, you'll have to do certain necessary engineering tasks. Testing, for example, or some extra security measure, for example. And this is something that was needed for a long time for the industry because you have to categorize different components at different security level. because something that is life-threatening impact will not be as severe as something that will have only privacy impact in case of security breaches. That's why CAL levels were extremely, extremely important. The way ISO SAE 21434, the current publicly available document, kind of prescribes or shows how you should do it is two-dimensional. In one dimension, you have the accessibility, whether you need physical access to the vehicle in order to perform a breach or an attack. Do you need a network access, or can you do it fully remotely, and so on. And in the other dimension, you have severity levels. What is the severity of the impact of the attack? So based on this, you will assign your CAL level. So this is how it's shown in the standard. Here, I would like to mention one important aspect to the security engineers who will be doing this, that please also consider the knowledge level of the attacker required when you'll be assigning the CAL levels. Because if the attacker can be performed by a script kiddie, definitely will not have the same severity, same CAL level as something that would require a nation-state level of knowledge.
A lot of people are currently talking about the standard ISO 21434 and its implications. You have made a very clear statement that in order to improve cybersecurity in vehicles, it is not sufficient to just follow the guidelines of the standard, but to do a twofold approach to cybersecurity. You mentioned that defense and offense as two concepts that should go in hand. So can you elaborate a bit on that?
Absolutely. So whatever we're talking about is most of them are defense. It's absolutely necessary. Defense is necessary. You have to secure the product engineering. You have to engineer the product in a secured way. That is important. And then after that, you have to continuously send patches in order to mitigate the vulnerabilities that will be discovered. You'll have to deal with incident management and so on. But these are all defensive mechanisms. Now, when it comes to cyber criminal industry, you're dealing with people who are systematically thinking of attacks. So a mere defense is never sufficient in such cases. You got to be ahead of your enemy. And that's why you have to be in offense. And what do I mean by that? When you're in offense, there are certain things you can do. You can create a honeypot in order to invite your attacker and see what they do. The concept that I'm talking about is actually out there already in the traditional IT industry. You just have to take them in order to implement it in automotive. You can't take it one-to-one. That doesn't. Automotive industry is a different beast altogether. You have to kind of like re-engineer it from automotive, but the concepts are interesting. Then you need an army of red team or ethical hackers who try to find exploits in your system with the motto that hack yourself before the bad guys hack you. And you have to also search for zero-day exploits, vulnerabilities yourself before they're out there in the wild. What does incident management mean? When something bad already happens, then you manage it. Then you ship the patch. Offense will give you another level of protection in a sense. The number of incidences should be minimized because you're in offense mode. You are discovering them before it is in the hand of the bad guys. So you're minimizing them. You're sending the patches earlier. So that should be the goal. This is how I think we can minimize damages due to cyber attacks, because otherwise, only a defensive mechanism is not gonna make you secured. Whether I'm saying that if offense and defense altogether can protect you 100%, no. But the idea is to minimize incidences.
And that is very relevant because the type of incidences we're talking about here might have drastic consequences.
Right.